Landscape Sampling and Spatial Interpolation Concepts. Objectives for this week are to understand key concepts of landscape sampling design, spatial interpolation, and combining vector and raster dataset to extract raster values. In ArcGIS, we'll look at the sampling toolset, the interpolation toolset, and the extract value to point tool. Learning objectives for this module include learning different methods for landscape sampling, understanding different interpolation methods and their impact on data creation, learning how to write raster information to data points, and learning how to compare accuracy of different interpolation methods. Landscape sampling provides two uses within a GIS. First, we can use samples to learn about existing data, such as accuracy assessments. Second, we can use samples to create or modify landscape data based on the sample information. Examples here include ground control points or information collected through scientific survey. A single survey can be used for multiple purposes. When conducting a landscape sample, the user controls two aspects. One, the location of each sample, and two, the number of samples or the sample size. Generally, we will withhold a subset of points for validation purposes. There are several different types of sampling design. Systematic sampling is generally uniformly spaced, easy to plan and retrieve data, but may introduce some statistical bias. Random sampling is based on locations which are randomly selected, the trade-off being there is less chance for bias sampling, but we may require more samples to acquire the same information. In cluster sampling, samples are taken in groups. This can be beneficial, especially for the concept of field design, where reduced travel time between sample points may be of benefit. Finally, we have adaptive sampling. With adaptive sampling, higher sampling density is intentionally placed on areas of greater spatial variability. This helps increase sampling efficiency. To use adaptive sampling, we must have a method for measuring spatial variability to determine where increased sample sizes are necessary. Sometimes when using an existing sample data set, we have little control over the number and distribution of samples. Here are some examples from Bolsted's text. A couple different tools in ArcGIS that can be used to create multiple sample types. For systematic samples, we'll want to use the fishnet tool. The sampling toolset can be used to simulate the construction of random, cluster, or adaptive samples. Spatial interpolation basics. Interpolation tools use discrete sample points to create a continuous surface of values. This can be used to fill missing values or to represent unobtainable values. Interpolation can be used for prediction over both space and time. Interpolation methods define the relationship between the sample points and the output surface. Output surfaces in general can be three types: isolines, polygons, or raster. The term exact interpolator is useful to understand how some interpolation methods return the exact sample point value to the output surface. Not all interpolation methods are exact interpolators. The remaining slides illustrate several examples of interpolation surfaces that can be created in ArcGIS. Please review the slides, the tool settings, and feel free to experiment on your own creating some of these surfaces within ArcGIS.